Hello everyone, I am here to discuss basic concepts of infrared spectroscopy. After studying this lecture, you shall be able to know what is IR spectroscopy, understand the basic principle of IR spectroscopy, know the concept of mode of vibrations in IR spectroscopy, and understand the applications of IR spectroscopy. Now, what is IR spectroscopy? Infrared is electromagnetic radiation. By using this, we can analyze the compound. Basically, functional group is determined. This IR spectroscopy comes under absorption spectroscopy and also known as vibrational spectroscopy because the spectra of a molecule arise in IR region due to the absorption of energy and transition occurs between different vibrational levels. Essential requirement of IR: if we are doing IR spectroscopy of any compound or sample, then sample should have a dipole moment. Two compounds will not show similar IR spectra if they are not enantiomers. When the IR light is passed through a sample of an organic compound, some of the frequencies are absorbed while some are transmitted. Then we plot an absorbance or transmittance against frequency IR spectrum obtained. These are the some wavelengths according to the near IR, IR and far IR. Now we will discuss types of molecular vibrations. Molecular vibrations are of two types. One, stretching vibration. Second, bending vibrations. Now we will discuss what is stretching vibration. Stretching vibration is the distance between two atoms increases or decreases, but the center atom remains in the same bond axis. Stretching vibration are of two types, symmetric and asymmetric. Symmetric when the both of the atoms move in and out simultaneously, whereas when one atom moves in and another moves out, called asymmetric vibrations. Now, bending vibration. Position of an atom changes with respect to the original bond axis called bending vibrations. Bending vibrations are of several types. Number one, scissoring. Two atoms approach each other with respect to the central atom called scissoring. Next, rocking. Both the atoms move to the same side and then both to the other side. That is, the movement of the atom takes place in one direction called rocking. Third is wagging. Two atoms move up and below the plane with respect to the central atom called wagging. And last is twisting. One atom moves up to the plane while other moves down the plane with respect to the central atom called twisting. Now, what is functional group region? It is extended from 4000 to 1500 cm inverse. Functional group region is useful for detecting the functional groups. Different functional groups absorb at characteristic frequency in this region of the spectrum. This table shows the various functional group having a frequency change and mode of the vibration. Now, what is fingerprint region? The region below 1500 inverse is very useful for establishing the identifier of a compound. Two identical compounds under the similar condition and in the same medium differ in their IR spectra in the region below can be identified easily. The region below 1500 cm inverse is rich in many absorption caused by a bending vibrations, rich in many absorption resulting from stretching vibration of Cc, Co and Cn bonds, rich in absorption bands because the number of bending vibration is usually more than the number of stretching vibrations. This is the table of fingerprint region. Now, we will discuss the applications of IR spectroscopy. IR spectroscopy are very useful for the identification of functional groups. Distinction between intra and intermolecular hydrogen bonding. In structure elucidation. Identification of unknown compounds. Now, let us discuss some practice question which is based on our presentation. Number 1. Define the term IR spectroscopy. Explain the types of vibration used in IR spectroscopy. Write the short notes on fingerprint and functional group region and discuss the applications of IR spectroscopy. These are the references. Thank you.